Hello, my name is Savas Katsouris, and today I'm going to demonstrate and explain the vertical jump testing. What is vertical jump testing? Vertical jump testing is a common method used by coaches to assess muscular power and jump height. The squat jump and the counter movement jump are two common tests that are used to distinguish the effect of the stretch shortening cycle in various athletic populations. A study conducted by Markovits and colleagues 2004 has shown that these tests are reliable and valid tests for the estimation of explosive muscular power. Additionally, Carlock and colleagues 2004 had demonstrated that peak power values derived from squat jump and counter movement jump can be valuable tool for assessing weightlifting performance. Furthermore, he revealed that this simple method can be used to identify potential talents in weightlifting since peak power has strong correlation with weightlifting ability. These two single tests can provide strength and conditioning coaches with useful information and can be used to identify deficiencies and imbalances in an athlete's performance. Coaches can then design more specific training programs to tailor athletes' needs, thus reducing the gap on athletes' deficiencies and increase their performance. Let's analyze one by one. The counter movement jump is a simple, practical, varied, and very reliable measure of the reactive strength of the lower body. It became very popular among many strength and conditioning coaches and sports scientists. The counter movement jump has been shown to be the most reliable measure of lower body power compared to other jump tests. Furthermore, the counter movement jump has been shown to have relationships with sprint performances, 1 repetition maximum, and explosive strength tests. These tests can be conducted either with or without the use of the arm swing. In case the test is performed with an arm swing action, the performance can be increased by 10% or more. The squat jump test, on the other hand, is typically used to measure an athlete's explosive lower body power. The squat jump is commonly used to test the concentric strength of the leg extensors, whereas counter movement jump uses a counter movement and typically yields a higher value than the squat jump because of the usage of the stretch shortening cycle. However, this is not always the case. Additionally, it is used to measure the reactive strength of the lower body as well. Both tests have various applications, like they give a solid read on peak power as it applies directly to most sports. Performances in the counter movement jump are linked with maximal speed, maximal strength, and explosive strength. Additionally, in terms of athletic monitoring, they can give a solid measure of preparedness based on physical outcomes. They are simple, valid, and reliable measure of power in the lower limbs. Power is of high importance in so many sports, and due to this fact, they have become a practical and useful tool among coaches and sports scientists to measure and monitor performance. Counter movement jump has also been directly linked with 30-meter sprint performances and relative strength during dynamic 1 repetition maximum in squat and power clean. Additionally, it's linked that those who perform better in the counter movement jump also perform better during sprint performances in 1 repetition maximum tests, such as the back squat and power clean. The counter movement jump is an appropriate test for athletes participating in sports which require high levels of explosive strength, such as football, rugby, basketball, Olympic weightlifting, and volleyball. Furthermore, counter movement jump has also been shown to be the most reliable measure of lower body power in comparison to other popular jump tests, such as the squat jump, a Balaghaus jump, sergeant jump, standing long jump, and the standing triple jump. Both counter movement jump and squat jump can be measured using different devices such as contact mats, infrared platforms, accelerometers, or linear position transducers and video analysis. But the gold standard of measuring counter movement jump and squat jump are the force platforms. Today, I will be using the infrared platform by OptoJump, which is an optical measurement system consisting of a transmitting and receiving body. How we measure squat jump and counter movement jump. Let's start with the squat jump. The participant stands with legs at hip distance, arms on hips, lower his body into semi-squat position, pause for 3 seconds. After the third second, he jumps explosively as high as possible. He has to attempt to land in the same position, and during flight, the participant must maintain extension in the hips, knee, and ankle joints to avoid any additional flight time. Counter movement jump, on the other hand, has the participant again stand with legs at hip distance, arms on hips, starts from the top, lowering the body until thighs are parallel with the floor, and jump explosively as high as possible. Again, the participant must attempt to land in the same position on the floor with hips, knees, and ankles extended during flight to avoid additional flight time, which will give us the wrong results. Now, for both tests, the participant must perform 3 jumps and will report the best score. According to Geller and colleagues 2014 and Lafayette 2014, jumps and peak power outputs appear to increase with larger counter movement depths. Having recorded the best score of squat jump and counter movement jump, after 3 attempts, we can calculate the eccentric utilization ratio, which is the ratio of the counter movement jump to squat jump. The result is a useful indicator of power performance in athletes. Athletes in sports such as soccer and rugby appear to have higher EUR values, which reflects the greater reliance on stretch shortening activities in these sports. It appears that the EUR can be used to track changes in training, with the values significantly increasing from off-season to pre-season. The EUR can give us valuable information about the performance of athletes and appears to be sensitive to changes in the type of training being undertaken. Furthermore, EUR can be used to determine the effectiveness of resistance training on lower body strength and power. EUR should increase as the athlete gets closer to competition. However, according to McQuiggan and colleagues 2006, these values are not chosen using a specific methodology, and they are related to specific sport. Now, what is stretch shortening cycle? Stretch shortening cycle is a natural type of muscle function such as walking or running, and it's composed of 3 muscle actions. An eccentric when the muscle elongates, isometric during the pause of the movement, and the concentric phase when the muscle shortens. The stretch shortening cycle forms the foundation of all dynamic movement. Comey and Bosco, 1978, and Comey, 1984-1986, demonstrate that concentric muscle wear was increased when preceded by active stretch, that is, eccentric action. Schmidt-Bleicher, 1992, classified stretch shortening cycles into 2 types. The fast stretch shortening cycle, which are characterized by short contraction times less than 0.25 seconds with small angular displacements, and can be observed in exercises such as depth jumping or hopping exercises. And the slow stretch shortening cycle, which are characterized by longer contraction times from 0.25 to 0.50 seconds with larger angular displacements, and can be observed in exercises such as counter movement jumps and box jumps. The equation to find the percentage of the stretch shortening cycle is as follows: counter movement jump minus squat jump divided by squat jump. This percentage is so important and useful tool for strength and conditioning coaches that allows them to design the appropriate program tailored to athlete needs, thus fulfilling any gaps, and as a result, enhance the athlete's performance. As a general rule, a 10% difference is an indicator that the athlete is in a good condition to begin the season. In the case where the percentage is greater than 10%, it can be an indicator that an athlete may develop force slowly. Therefore, activities that focus on rate of force development, such as strength training, may be beneficial. Lastly, in a case where the percentage is less than 10, it can be an indicator that an athlete may have underdeveloped stretch shortening cycle, and therefore activities that focus on reactive strength, such as plyometric, may be beneficial. To be more precise, sports conditioning coaches seek to have a 10% difference in their athletes, which is considered the optimal for performance. This applies more to sports which require effective use of the stretch shortening cycle in vertical jump sport, such as volleyball, basketball, etc. In the case where the difference is 10%, it's an indicator that the athlete is in good shape to start the season. Even though the athlete has a good transfer of energy and power efficiency, he must try to bring his capabilities at a higher level. In a case where the stretch shortening cycle percentage is less than 10, the athlete's power is in excess compared to explosive energy. The primary focus should be on developing proper usage of the stretch shortening cycle, and can be achieved by incorporating more plyometric reactive work than strength training. The 2-to-1 ratio plyometric to strength can be used. It's wise to begin with simple plyometric exercises such as pogo jumps, drop jumps, continuous hurdle jumps, and gradually move to more intensive plyo exercises. Professional strength and conditioning coaches go a step further and use the reactive strength index to design training programs tailored to athletes if they lack explosive energy. What is reactive strength index? Reactive strength index is a representation of the fast stretch shortening cycle potential. It assesses an athlete's ability to change quickly from an eccentric to concentric contraction, and their ability to develop maximum forces in minimal ground contact time. Reactive strength index can be measured using drop jumps from a box onto an electronic jump mat. Additionally, reactive strength index is a ratio between ground contact time and height jump. As a result, both these variables need to be considered in conjunction with the overall RSI score. If the RSI is equal or less than 1.5 seconds, lower intensity plyo exercises such as pogo jumps are more suitable for that athlete. If RSI is 1.5 to 2 seconds, moderate intensity plyo exercises such as tuck jumps will be more appropriate for that athlete. Lastly, if RSI is 2 to 2.5 seconds, higher intensity plyometric exercises such as drop jumps will be more suitable. In case where the stretch shortening cycle percentage is greater than 10, it indicates lack of strength on an individual. This athlete will benefit greatly by incorporating pure strength work into their workouts. The exercises should include low rep with maximal force and in each repetition to ensure a high quality workout. Rest between sets should be enough to ensure maximum recovery between sets. Nowadays, strength and conditioning coaches dealing with professional athletes make use of the force velocity profiling, which is a simple way to assess an athlete's force and velocity production capabilities during ballistic tasks such as jumping and sprinting. Force velocity profiling can detect deficiencies of force or velocity of an athlete during a specific movement. Specific training programs can be designed to reduce those deficiencies. The principles of the force velocity profiling are based by the force velocity curve. Force and velocity have an inverse relationship, which simply means an increase in force will have a decrease in velocity and vice versa. Identifying where an athlete is deficient will help strength and conditioning coaches design an appropriate training program to reduce those deficiencies. The main aim of sport coaches is to shift the first velocity curve to the right by incorporating pure strength work into their workout, the performance of the athlete in both force and velocity. For the sake of the conversation, if an athlete has deficiencies in velocity, the training program must focus on maximum velocity and speed strength with using loads from 0 to 60% of one repetition maximum. Exercises such as band, assisted, counter movement jumps will help the athlete to increase maximum velocity, whereas exercises such as squat jumps will increase speed strength. In the case where the athlete is deficient in force, the training program must focus on strength, speed, and maximal strength using loads from 80 to 100% of one repetition maximum. Exercises such as power clean will aim to enhance strength speed, whereas back squats of 1 to 2 repetitions maximum will increase maximal strength. Another important indicator for the strength and conditioning coaches is the calculation of peak power. Power output is an essential component in many sports, where jumping is involved, such as volleyball, basketball, etc. The ability to assess jumping power can also aid in the evaluation of an athlete's progress or in the determination of a training program effectiveness. The Sayers equation can be used to see if changes in body mass and jump height are favorable to our training objectives. According to Sayers and colleagues, 1999, the Sayers equation has a greater accuracy than either the Lewis or Harman equations. The formula to calculate peak power using the Sayers equation is as follows. Peak power in watts equals 60.7 times jump height in centimeters plus 45.3 times body mass in kilos minus 2055. Although weight training, plyometrics, and weightlifting have all positive effects on lower body strength and power, according to Garhammer 1992, weightlifting and plyometrics have a greater potential to improve performance compared to weight training. Additionally, Baker 1996 suggests that dynamic type of strength training is superior to general strength training program for improving vertical jump. How often should we do these tests? There is no need to execute those tests very often. It will be a good idea to use these assessments at the beginning of an off-season training plan and then again at the end of each training phase to observe how athletes are adapting to the training. And if there is a need to modify training plans in order to enhance athletes' performance. I would like to thank you for watching, and I hope you found this video helpful and educational.